I printed off his resume, a little bio on the web, and Michael, who's an old friend, was kind enough to point out that at my advanced age, it's probably too small for me to read. He says to me, "I never miss a cheap shot when it's an old friend." But I can sort of make out that he's the director of the California Lighting Technology Center. I know from my own experience that he's a truly remarkable innovator who has brought very unusual energy to the field of lighting, and particularly to a corner of the lighting field, maybe not a corner, maybe a division of the lighting field that's a little different from what we usually think of, which is lamps. And his focus, not that he is exclusively focused here, but that one of his great focuses is on fixtures, on how to put the lamp into a good application. And the point is the lamp manufacturer is quite concentrated, whereas fixture manufacturer is very, very fragmented, so that Michael's playing a key role in supporting an industry that really can't sustain an R&D agenda on its own. He's a remarkable leader, and you'll see a pretty high-energy speaker. With that introduction, I'm going to say hi, Michael. I'm really glad you could come today.
Thanks so much. First of all, thank you very much for inviting me to come down to Berkeley. I spent almost 20 years sharpening pencils up the hill before I moved out to UC Davis to sharpen more pencils. So again, many thanks for inviting me down. California is in a really interesting place, and what I'm going to do is talk a little bit about the juxtaposition of policy, technology, and sort of the kinds of things that we're doing in the R&D arena at the university to pull these kind of worlds together, and how does it interface with the industry, and what is the lighting industry doing, et cetera. And I use this slide a lot with my regulatory friends up at the Energy Commission and at the legislature, and it really sort of shows the challenge of myopic thinking that we face in the whole land of lighting technology. And you're probably all very familiar with ban the incandescent lamp, and this was something that was sort of very key in the dialogue, recent dialogue about new technologies. And the problem with simply banning technologies is that you end up with a smuggling mentality, and that what we really want to do is develop new technologies, more advanced technologies, and best practice solutions to overcome this type of challenge. So what I'm going to talk about is looking at this as an opportunity. It's a research opportunity, and I think more importantly, it's a business opportunity. It's an opportunity for the American industry and California researchers to come together to address the kinds of deep, important problems we have with efficiency and climate types of issues. I'm a professor at UC Davis, and I'm also the director of the Lighting Technology Center. And I'm going to talk a little bit about some of the activities that we do in this middle ground between research, innovation, and the work that we do with the industry. This is a slide from my midterm exam that I give the students in one of the lighting classes that I teach at Davis. And I do the typical, please find the 10 wrong things with this building. Okay, so the students go ahead, and I do point out that it is an architectural design award-winning building, and the students go ahead and point out all the wrong things about the massive amount of south glass that we have on a building that's in the Sacramento area, all the lights that are on in the evening, all the exterior lighting, all those kinds of issues. So the students go through and try to figure all this out. One of my students dug into this further and looked at the whole stairwell and actually calculated that 40% of the flux, of the light flux, is actually exiting the building without suffering a first bounce, which means it's just lighting up the night sky. And so it was a very diligent calculation that the student did, showing that all this light was just leaving. It's too bad that the architect couldn't have gone through this simple kind of little mental calculation. We have challenges, and the kinds of challenges that we have with the way we light buildings, the way we use energy, are actually quite simple. This is, again, another university building, and all the lights are on 2:30 in the morning. And I have to tell you that there are no hardworking professors inside the building. And I know this because I went up to the door, and the doors were all locked. Okay? So $40 worth of technology could have taken out these lights with a simple sensor, be off at 2:30 in the morning. So I think as a culture, we miss the very simple kinds of things in terms of energy efficiency and sustainability. This is an area that I'm working deeply in right now with the whole codes and standards. We're engaged in the energy bill, the Senate energy bill, and then some recent modifications to ASHRAE. And I'm working very diligently on Title 20 and Title 24 to try to ensure that the kinds of things that you see in the slide doesn't happen. Okay? And there's a tremendous amount of waste that we have in this country in the way we use light. Simple things like we do a really good job in this country of daylighting our buildings, but we do a terrible job of what's called daylight harvesting. And daylight harvesting is just a very simple construct in which you turn off the lights when there's available daylight. Okay? And this simple kind of illustration shows you here a fairly massive waste. Not only are we suffering the thermal loads from the glass, but the lights are all on when they could be switched off with, again, very simple technology. Less than 5% of the buildings in this country use any form of daylight following system, of the simplest form, And so we've got a long way to go just to do very simple things. This is actually one of the projects that I did that actually started this. This is the Mondavi parking lot. And as you drive between Sacramento and San Francisco, you go by one of the largest exterior parking lots around. And it's massively lit up with HPS, high-pressure sodium lamps, all night long. And of course, there's nobody here. And so this whole project started, what could we do in the codes and standards process to address this kind of issue, this kind of waste? As a metaphor, this little lonely truck in the middle of the night in this massive parking lot. This doesn't need to happen. We're still addicted to incandescent light sources, heaters, for our primary source of light in our residential applications. And this has been a real national as well as statewide failure in terms of how we put technology and policy together to get next generation technologies in play. You go into a typical showroom like this, you'd be very hard pressed to find anything greater than 10 lumens per watt in terms of its efficacy. And so we were really very challenged in terms of how we use more efficient sources and systems. A typical contractor-built kitchen in California uses about half a kilowatt per kitchen, and this is large. This is an enormous amount of power to light a kitchen, and we can do a lot better. And this is a real illustration of the lack of connectivity between technology, best practice, and the kinds of things that we do. California's done some very creative things. I mean, I think California has been a real model in terms of energy efficiency and demand response are the kinds of things that you do first to address our energy needs. Other parts of the world build power plants first, and then they think about energy efficiency. In the state, we look at energy efficiency and demand response. And California is kind of unique. If you look at its per capita electricity consumption, from 1960 to present time, if you look at the United States as an aggregate, we sort of see this progressive per capita electricity consumption. And this is what I think of as reflective of the American way. It's just more and more. It's like, you know, more refrigeration, more lighting, more stereo equipment, more computers. It's just increased consumption. In California, since '74, we've kind of flattened off in terms of our per capita. Not of our total, but our per capita. And what this is partially illustrative of is our insightful codes and standards, our appliance standards, the way we build buildings. And it reflects a success story that's happened in California that's being replicated in other parts of the world. Building on this success story is what could California be doing in addition to the codes and standards process with appliances and building standards. And the recent Huffman Bill is putting in front of California some real game changers. We're looking at some very, very ambitious goals for California in terms of our energy efficiency objectives. The first one is looking at a 50% reduction in residential lighting in terms of energy. Huge objective. This is going to be a real game changer in terms of how we build homes and how the industry responds to lighting equipment. Further, we're also going to be looking at a 25% reduction for commercial lighting and for exterior lighting. The Huffman Bill alone is probably going to be one of the single largest business and research opportunities for lighting that we've ever seen. And typically, we see an adversarial relationship between industry and codes and standards processes. But in this case, industry is ready. Industry wants to work with California, wants to address these, looks at this as a way of selling more expensive equipment. So in this equation, everybody will win. California is going further. It's linking energy efficiency and renewables with the concept that at some point in the future, it will be zero net energy. And the concept here is that you can reduce your load inside a building to such a small amount that now you can use renewables for the remainder and end up with zero net energy. Now, this is an extremely ambitious goal. And are we going to make it? It's going to be difficult. But what it reflects is a real change in vision in being able to link these two things together. What's happening now is the concept of linking renewables and efficiency together in terms of lighting has led to this statewide dialogue going on called the Strategic Lighting Plan. And the Strategic Lighting Plan is a document that we've been working on broadly as an industry, looking at what could California be doing by 2020 in terms of linking both efficiency and renewables together. And the goals are going to be something like 60 to 80% reductions in electrical lighting energy. Okay? Massive game changers in terms of how we build and light buildings. So if the strategic lighting plan moves forward with these types of goals, what it means is that all the lighting in all of our offices, homes, places of work, places of play will all be changing to something new and more efficient. So this means that we have a really, really aggressive goal, but enormous business opportunity. So where do we all fit in this? The Lighting Center at Davis was established about 10 years ago with the idea of what could an innovation center do working collegially with the industry, the utilities, and the Energy Commission to help address some of these emerging challenges. So we were created at Davis to do research and development with the lighting industry where we develop new technologies, do demonstrations with our university and state partners where we take technologies and we put them into practice, work a lot with the industry folks to do training and education, and then to engage in the codes and standards process. California's got a very aggressive codes and standards process where we're developing better ways to build buildings. So there was an agreement between NEMA, National Electrical Manufacturers Association. These are the folks that make the lamps, the controls, the ballasts, all the electronic gear that goes into buildings. They had an agreement with the Department of Energy, with the folks at the Energy Commission and UC Davis to create this innovation center to address these kinds of issues. And this was about 10 years ago. The broad mission objectives, the kinds of things that we do, are based on three pillars. One is we need to support technological innovation. We need to support innovation both by the universities, but also by the industry, and we're working together collaboratively. We need to see this as a business opportunity. Something needs to be sold at the end of this innovation process. It's one thing to write the scholarly paper, but we have to actually engage in the development of new products and new systems that actually get sold into buildings. And then finally is getting into education and training, is developing these best practice solutions and teaching folks how to install them, how to implement them, how to design with them. So this is training all the way from the electrical contractor to the engineer to the architect. So we become reasonably adept at crossing the valley of death. And what this means is that there's lots of really great ideas in basic research, things that exist in laboratories, but actually moving that into the marketplace where something is sold and something is saving energy is another issue. And what we've done is we've learned that by working in broad industry partnerships, we can move technologies from lab to marketplace. So this has been our sort of main way of working. We do lots of things in terms of looking at all the way from product visioning, working in the laboratory, testing things in the market, and then working in codes and standards. So we follow the complete food chain all the way from laboratory all the way out to where we're putting things in buildings, and we're working with the codes folks on developing next generation standards. A unique part of our model is that we're very linked up with the California utilities. And the California utilities are a tremendous catalytic agent for change in this state. They have a lot of programs, they have a lot of funding, and they have access to the marketplace that we don't have. And so what we've done is we've formed strategic partnerships with utilities, so each one of their emerging technologies folks sits on our board of directors and helps guides us on projects in terms of making marketplace connections. We have lots of industry partners. Between 50 and 60 industry partners at any one particular time. Industry partners are people that work with us on research projects, collaborate with us on demonstrations, and work with us on the development of new visions leading to codes and standards efforts. A big part of our work is partnering between the industry and state institutions to affect real change. We're about 25, 30 folks. We have electrical engineers, physics people, we've got optics people, marketing people, architects. So it's a broad cross-section of scientists and engineers. We have a state-of-the-art lighting laboratory. We like to think of ourselves as one of the best publicly owned lighting labs in the country. We have all the different types of apparatus needed for developing new types of lighting systems. So now I'm going to go through a number of the different kinds of areas where we're working, some of the new technologies and some of the programs that we're accelerating. We're very deeply ingrained in the whole LED, light-emitting diode arena, and we think that this is going to be a real growth opportunity for California, particularly in addressing a lot of these efficiency opportunities. We have very close partnerships with the building industry. Actually, the building industry sits on our board of directors and sort of helps us with information and partnerships. We did a fairly large survey of homes looking at where are we in California in terms of energy efficiency and what about Huffman and how are we going to be able to plug in next step legislation to make efficiency happen. And so we looked at a cross-section of homes, and this was 2007 homes that had been built. And what we found out was that about 60% of the light points in a home that was built in 2007 is what we would call energy efficient, using most likely a fluorescent or a compact fluorescent light source. And so this is actually a pretty big success story. I mean, so we said, wow, 50%, that's a really good success story. And this is predominantly driven through Title 24 and some new developments with the industry, availability of new next generation technologies, electronic ballasts, compact fluorescent fixtures, all these issues that we were involved with. So this was a very big success story, something the state was really proud of. Well, we dug a little bit further, and if you look at this 60%, this is 2007 homes. If you actually look at what of the total subset of existing construction, it's a very thin part of the pie. And so what that means is that we're doing really, really, really good on a very small subset of the overall buildings. And these are, and the rest of the blue section here, this 80%, they're still using heaters, incandescent lights to light their home. So in one case, we made tremendous progress, but the sad reality is that we're still using very inefficient technology to light most of our homes. And so I worked a lot with my industry partners, and I got a lot more data, and the number turns out to be approximately 15%. About 15% of the light points in the home today are compact fluorescent. And again, in spite of massive amounts of money that the state has spent on energy efficiency and on programs, on rebates, we still don't have much market penetration in terms of compact fluorescent. And there's some technical reasons, some policy reasons, and some human factors reasons why this is happening. And one of the issues is that we found out that there are about 10 dimmers. And if you look at a new home, there's about 10 dimmers in every home. And about 90% of the incandescent fixtures are on dimmers. And we know that compact fluorescent lamps don't dim well. So what happens is the consumer goes out and buys a compact fluorescent lamp, takes it home, puts it on a dimmer. It doesn't work. And what we end up with is an unsatisfied customer. And this is why we have 15% market penetration. So this is a real critical barrier if we're going to try to get California 50% energy savings in residential applications. And if we only have 15% market penetration now because people dislike compact fluorescent, we've got some real technical problems here. So we looked at this a little bit more and we said, look, if we look at projecting out from 2007 buildings out to 2018, which is the time frame for the statewide legislation, is that if we do nothing, in other words, if we just keep going on the way we're doing things, we're just going to barely keep up with growth. And this is actually a success story. Because if you look at Texas, Texas doesn't look like this. Texas looks like this. Okay? So California, flat, it's pretty good, but it's nowhere near Huffman goals. Okay? If you change out every socket in the home, every light point in the home to 40 lumens per watt, we can actually get to 50% savings. So this is the kind of thing that we're looking at in terms of trying to bound this problem. That means that every light source that you come in contact with at home needs to move to 40 lumens per watt. And we need to do all the technical human factors. We need to do all the right things in order for this to happen. One of the opportunities is with LEDs. LEDs offer both the technological and the human factors experience to help leapfrog over compact fluorescent to get into this. This is actually an experimental kitchen that we have up at the Lighting Center. And all the panels in here move and slide. It's all heavily instrumented. And this kitchen is entirely illuminated with LEDs, and we're lighting it within acceptable standards at about 100 to 150 watts, which is it's about 50% what's going in today for Title 24. So this is a real jump forward. If you look at a typical kitchen in California, it's about 700 watts. My parents' kitchen, 700 watts. If you look at my kitchen, it's about 300 watts. But we think we can get to 100 watts. Okay? And we could do that with a level of color, a level of customer experience, and a level of control that will make people want to put that system in. And so this is where we're headed. If we do these kinds of things, we're going to come a lot closer to addressing the kinds of Huffman goals. We need to address human factors issues. A lot of the issues we have with energy efficiency are cultural or human factors oriented. They relate to color and control. We have massive problems with glare associated with LEDs and the ability to control brightness inside a space. We've done all kinds of studies where we've put these into homes. We've looked at the energy efficiency. We've measured power. But we've done a lot of color studies, and we're looking at how do people like the glare? How do people like the color? How do people like cooking underneath these types of lighting systems? Very important. But we're getting very good energy savings, but now we need to start looking at the customer experience and color qualities. We're looking at tying these things in with PV. We're doing a lot of PV work in the state, and we're going to be doing a lot more. And we're seeing a lot of builders aggressively pursuing PV, where they're running the power back on the line. We're looking at the concept of using this as a demand response or demand capability, where you use an LED lighting system in a 100 watts region. You're now down at a very low power level where you can start using integrated PV. We've put together partnerships with large manufacturers of this and large manufacturers of this. These folks don't talk to each other. So now we're working a partnership where we're going to be bundling these things together for homes. And the idea here, if you look at a typical power demand during a day, you have this very asymmetric type of structure where towards the evening hours, you get this coincident peak power where you've got folks coming home, people still in the office. These things build together, and you get this peak where the poop hits the fan between 4 and 8. The power company can't generate enough electricity, and we have some serious power demands here. So if we could pull off 5, 10, 15% reduction in load during these hours, it would be a great accomplishment. So what happens when mom and dad come home is the first thing they do is they turn on the lights and the air conditioning. So if we can pull off 15% off this, it could be a real benefit. So we put together a partnership looking at the idea of integrating PV, where we would charge during the day when no one's home, and then bleed off a small battery in the evening for the kitchen lighting. So this is looking, we had a big chunk of funding to develop the first prototype on this, and now we're moving to the next step with utilities. Through the PEER program, we're doing a lot of efforts looking at how can we be lighting next generation offices, both new construction, but mostly focusing on retrofits. How could we retrofit California's building stock to generate 50% energy savings inside office spaces? California is typically illuminated like this, and we all work in offices that look like this, where you've got a sea of fixtures going on forever. It's glary, it's too bright, or it's not enough light, or lots of shadows. We're typically 1 to 3 watts per square foot for typical office spaces. And so we've got a lot of room to go. So we developed this whole concept of looking at how can we integrate task lighting, task ambient lighting, using LEDs for office spaces as a retrofit. And so California is making real steady gains in terms of bringing down power densities. We're down into the 1.2 watts per square foot for new construction. But how can we go back and capture all the energy savings in the buildings that already exist? So the concept here is the next step for new construction is getting down into the 0.5 watts per square foot region, but doing that with next generation lighting of integrating LEDs and controls together. Problem is we're all getting a little bit older and we need more light. I'm starting to wear glasses now. And what happens is as we start reducing lights inside spaces and we start getting older, we need more and more light. So these things are juxtaposed. They oppose each other. So we need to look at not just developing more efficient lighting, but developing better lighting. So we developed this whole project called Task Ambient, and looking at the idea of putting very high quality lighting in the near environment and reducing the amount of ambient lighting inside of a space, principally to reduce glare. And so what we developed was what we're calling the personal lighting system, which is an array of LED lights that are positioned over an entire cubicle to provide a very high quality of light with very low glare. And so the concept is very simple. It's putting light where it's needed, providing very high levels of user control. We know that the Trojan horse for energy efficiency is user control. When you give people control over lighting systems, they like it. They like it. And this is not a new finding. So what we did is we put very high performance, low glare lighting, very low screen glare, but lighting systems that people actually want to use. And not want to use because they're saving energy, but they want to use because it's the preferred light source for their environment. We've done all kinds of testing inside offices. We developed all kinds of prototypes. We launched industrial partnerships, and we've lit all kinds of buildings on this. And the idea is that this whole system is a integrated LED on a very flexible series of task lights under cabinet lighting, and it all works together off a central engine, and it can be rapidly deployed as a retrofit system. We've done all kinds of key buildings. We've got a very large project going with Southern California Edison called Office of the Future, where all office lighting for their next series of incentive programs will be based on this. We just finished doing a large study at the Ziggurat building in Sacramento where we relit the offices there with this. We've done large demonstrations with Sacramento Municipal Utility District. And lots of installations in Sacramento. We got a DOE award for new technology. This thing's now commercially available. It's integrated with sensors, and so we get occupancy-based sensing on this as well, so we get an additional 30% savings. This is my laboratory. And so what I get to do is when we develop new technologies at the Lighting Center, is we have agreements with state agencies and campuses when we develop these technologies is to walk in and relight offices and workspaces with our lighting systems. And a classic example is this. We both work for the same person here. So we relit a portion of the offices up at UCOP with this task ambient lighting system. And so there was a little bit of stress doing this project. And the dean was very concerned about just how well this was going to work, and are you sure, and all the rest of it. So we went in, we did before and after. We got about 44% savings before and after, close to the target. And again, the idea was relying on task ambient, where we put very high quality lighting in the near environment, high level of user control. We backed off on the overhead lighting so there wasn't so much glare, and people really liked it. And incidentally, we get 50% savings. So this is just showing one of the installations. It's got high performance LED task lighting in the near environment, very controllable, very movable, very simple equation. This isn't rocket science to get. Again, the idea is that these sort of free-floating task lights positioned throughout the task plane that the people sitting can position themselves. So there's thousands of these offices now that we've done. Again, very nice lighting quality, happy employees. Okay? We've done so many demonstrations across the country. The best thing that you want to hear from a building demonstration is nothing. Because all the calls back that you get when you say, my lighting system won't work. We did an installation up at the state with the head of one of the state agencies, which I won't name. And each one of these little lighting kits has a little occupancy sensor that sits on the desk. And so the secretary of this director calls me and says, Michael, you need to come up. The lighting system's not working. The director's really, okay? So I hop in the car and I drive to Sacramento, and I find out that the sensor's underneath a piece of paper. And I say, Madam Director, the sensor needs to be open and exposed so that it will see you when you walk into the office to come on. The director says, thank you so much, Michael. 2 days later, the phone call rings again. It says, Michael, she's really pissed. You need to get up here. So I go up and I say, Director, same problem. So this was, I said, director, this is becoming a very expensive house call. Okay? You're having a professor drive all the way from Sacramento, from Davis, to come and tell you not to put a piece of paper on the sensor. Okay? So we learned from that, and of course now we're using different, that was my fault, not her fault. So we're very involved we're working with the two furniture companies looking at next generation LED lighting, both Steelcase and Herman Miller. We're looking at how can we integrate next generation optics and LEDs and controls into furniture integrated systems. Okay, so the idea is that when you purchase the furniture, this whole array comes with it. So this is sort of a very, we're doing a lot of testing, a lot of optics work, we're doing a lot of glare measurement work, and then we do demonstrations at the universities, and then we go out and products commercialized. So this is sort of typical flow on this kind of activity. Lots of human factors work. So I'm going to focus the rest of this talk just on what we're calling the Smart Lighting Initiative. And this is something that our partners wanted us to get into, and it's really sort of a primary area of concentration that I'm working on now. Not in my bathroom. But we really got this project we did a big project with the state looking at what could we be doing with all the waste that we see in bathroom lighting. And what happens typically in a bathroom is lights are left on for long periods of time, particularly in hotels and in public institutions. Okay? And it turns out that we could get about 75% energy savings if we just turned the lights off after an hour. Okay? Very long set times. And so I actually gave this testimony at the state to the legislature, and I said, if you folks use simple occupancy sensors in your bathrooms here at the state, we would get 75% energy savings, because even in our state buildings, we don't use the simple technologies. So the idea is simple occupancy sensors after an hour set time will get massive savings. So we got code change. Title 24 now requires occupancy sensors in new construction beside bathrooms, or pretty close to requiring it. The idea is very simple ideas like this, with the right kinds of set points on this, can be something that can be put easily into institutional bathrooms. So this was a very big success story for us, and we started brokering partnerships between the industry. I got the industry to stand up at the legislature and say, this is good stuff, let's put it into codes, as opposed to pushing back on it. Okay? So everybody's making more money, state is saving more energy. Okay? We're doing a lot of work on daylight harvesting systems. Again, we do a really good job of bringing daylight into buildings, but we do a terrible job of turning off lights in response to the available daylight. So we've put together a partnership with the utilities where we're looking at very simple switching scenarios. And here, what we tested was when you walk into a perimeter daylight office, the lights will come on automatically to 50%. They will then go manually on, meaning you push the switch to 100. It will go manually off when you leave, and it will go manually off if you choose to do so. So what we did is we tested this. We went into a series of buildings, we tested it. This is the simplest thing you can do, but what it does is it relies on the human factor for the savings. When you walk into a perimeter daylight office and the lights go on to 50%, we proposed or theorized that most people wouldn't do anything. They would live with the fact that they've got 50% of the light coming in from the daylight and 50% from the overhead light, and the two together would be enough for the person to do nothing. No sensors, no daylight following system, no tracking, no Zigbee, no nothing. Okay? And what we found out was this. That 70% of the time, people did nothing. They lived with 50% of the power, 70% of the time. 17% of the time, they chose to go over to the wall and turn the lights off. And then 13% of the time, they chose to turn the lights fully on. And you can see similar types of offices. This person here, they really, really disliked electric light because 99% of the time, they got up and turned the other light off. This person over here, on the other hand, they really liked electric lights because half the time they switched the light on. Now the concept here is that we got massive savings. Now this is over Title 24. Okay? So we're getting 70% savings over Title 24 by choice. People are choosing to do it. So this was really a unique experience. So what we're doing now is we're launching 2 massive demonstrations with the utilities where we're doing whole building clusters with this to test this to see if we can now modify the code to include this. So very large savings without any of the irritation of any kind of daylight following system. Another big struggle is stairwells. The only people I see inside stairwells are the folks trying to get exercise running up and down the stairwells. These things are lit 24/7. So through the peer partnership, Public Interest Energy Research Program, and the Energy Commission, we looked at developing a series of bi-level solutions. And the concept here was that the fixture would go from 100% light down to 50% light when there was vacancy. Okay? And so the idea here is what we want to do is by 2015, every single stairwell in the state we want to change out. Because right now, very few of the buildings, less than 1% of the buildings, have any form of bi-level stairwell. And it's an easy opportunity. Simple integration of sensors on the fixture will take it from 100 down to some lower level when no one's around. You don't want to turn it off, you just want to turn it down. This is a before and after at a university. Before we put the sensors in, static load, 3,500 watts. And then when we turned it down, you can see each time someone goes into the stairwell, the lights blink up to full level. Massive savings. Everybody likes it. We're collaborating with CIE, California Institute for Energy Efficiency, where we're looking at group purchases, working with our university partners, trying to transform all of our university partners to this technology. And so the whole concept of smart lighting is something that we're looking at for exterior lighting. Huffman Bill addresses this explicitly. Okay? 25% objectives for outdoor lighting. And this is probably going to be one of our biggest success stories. It's also that's very tied into the kinds of thinking that's going on now. I just did a program with the mayor's office at Davis where they're really looking at aggressive use of LEDs and looking at dark sky issues. This is from one of my partners in Alaska. And you can read a newspaper inside the home without all the lights off because there's so much light pollution from these things. So this is a real problem. Lots of new technologies coming into play. New lighting controls technologies, LEDs. These things need to be working together, and that's what we're looking at is the synergy of the two. Also, the municipalities are going broke, and municipalities are struggling, and some of them, the lighting bill represents a sizable portion of their budget. So we're looking at how can we address municipal lighting. So we developed this thing called the Smart Lighting Initiative where all exterior lighting will reduce to 50% when no one's around. And then when there's occupancy, the lights will boink up to 100%. I started this project with the police department because I wanted the police and the security people working with me at the very beginnings of this project. And the thesis is that a dynamically responsive lighting system is inherently more safe and more secure because it heightens awareness. And we're getting buy-off on that across the board. And the idea is that we're targeting all parking lots, garages, pathway, building, and signage across the state, all lighting for bi-level. And so this is a bi-level pathway lighting at a university, middle of the night. I can assure you there's no professors working in this building when we took this picture. So the lights are now down at 50%. And there's a little bit of intelligence resident in the fixture, and there's lots of different ways to do it. We're partnering with a number of large manufacturers, large and small manufacturers to do this. And again, simple sensor technologies can reduce the light from 100% down to 50%. We're working with different controls protocols. We're working with different sources. Again, we're agnostic. We're technology neutral. A number of different ways to do this. We've done all kinds of tests and all kinds of demonstrations. This is now commercially available, and there's precious few new pathways or walkways that are going in the state that are not using this. I have grad students running around at all hours. But this is this massive glowing beacon at midnight, and there were 6 cars in this parking garage, and this is a real shame. Great daylight opportunity here. 4 cars, midnight. Municipal parking lot, 1 car. This is a school. They can't afford to buy textbooks, but the gymnasium lights are on, all the wall lighting is on, all the parking lot lighting, and there's no one around. So this is the ideal target for this code modification for bi-level. So we launched a statewide initiative where we would look at parking, walkways, surface lots, building lighting, all being dynamically responsive to occupancy vacancy. So we started off with some experiments. We looked at simple sensors. Again, very simple technologies integrating. We tried all kinds of different approaches. We worked with a broad cross-section of manufacturers. Again, simple pole-mounted, fixture-mounted sensors. We looked at RF systems, and actually we're doing a lot of work now with RF systems and LEDs, where we're looking at broadcasting signals across surface lots and being able to, and we're putting together this white paper now calling for a national standard for all surface lots to be tri-level, and I can chat about that later. We partnered with the LED manufacturers. We integrated simple sensor technologies that would make this fixture go from 100% down to 50%. Again, very simple protocols. We did all kinds of the chancellor really liked this. It said the guy wore his UC Davis t-shirt here. Chancellor types like that. We did lots of demonstrations. We relit the Mondavi complex up at Davis with all smart lighting. We had the governor's office out. We cut ribbons, and we became an LED university using smart bi-level. Here you can see the sensor on the face of the fixture here. Again, most of these early systems that we did were integrated on a fixture-by-fixture basis. Lots of installation work. They wouldn't let me drive the little truck, though. Lots of parking lots. This is at 50% light. And again, camera doesn't really show it, but the surface lots is at 50% when no one's around. And then as soon as somebody drives up here, the lights boink on to full level. We did a big demonstration program, early demonstration at Sacramento State, where we went from HPS, high pressure sodium yellow lights, to bi-level LED. So this is a before and after picture. And again, here, there's nobody around, and now we're at 50%. This is actually at 30% light. The nice thing about white light is that you can actually see a little color in it. You know, it's becoming more flexible to using white light. We got 68% savings before and after. And I'll just draw your attention to this is just a typical day. And here the light is at full power, and then there's nobody around. It dims down to 30%. And it's down at 30% most of the night. Someone drives in at 5 o'clock in the morning, light boinks up. And then the light's off at 30%, and then it's on the rest of the day, as it should be. People are driving in and out of the parking garage all day. And then these are all people escaping. Okay? And it shows the escaping from work. So 68% savings. Universities are doing this like crazy. They're trying to light every. This was probably the most pivotal parking lot in the state. This was a small parking garage at the west end of the north end of our campus. And Wendell Bross, who's the sustainability coordinator for UCOP, came to see this and was really impressed with the energy savings and the safety and security enhancements, and has been working with me establishing this as a statewide directive for all UCs across the state. UC Davis has completed all of its parking structures. UC Irvine has completed all the structures. UCLA is in the process of converting all of its structures. UCSF is in the process as well. So this is a fairly massive relighting. This is one of the largest surface lots. This is the Mondavi Performing Arts Complex at UC Davis. And I think there were like 2 cars in this picture. It's all HPS. We just finished relighting that to bi-level, and we're getting about 70% energy savings before and after with this, and it's better lighting. I couldn't get them to cut the trees, but I said the trees are blocking a lot of the light. The other thing too is there's a whole heat islands issue as well. So the process on this, again, it's a marriage of technology, policy, and how you work with the industry. What we did is we developed a statewide goal for all public buildings. All public building exterior lighting will be bi-level. This was sort of a directive. We presented this to UCOP and Department of General Services at a high level and said, we want you to adopt this as a directive. You take this on and you go do it. Okay? We then presented this to NEMA, the manufacturers, and we asked them to endorse it. We said, please build these fixtures. And now we're tying in with Title 24, and we're going through the processes now of changing Title 24 and Title 20 to provide the underpinnings for this. Okay? And so I'm less concerned about that happening. That's just a process. And the draft language on that is going to be something like, all fixtures will reduce to a minimum of 40% when there is no activity adjacent to each luminaire or grouping of luminaires. Okay, I'm going to wrap up here. Last one, I'm going to show just a couple of slides on, we're doing a big program on LED cooler cases. We do a pretty intensive job of lighting our sugar water in the state. And that whole marketplace is transforming over to LEDs. And we're really interested in it because it's a great area to play with color, also with lighting controls. And I'm going to sort of show you we put in sensors and controls on this with the idea that we're playing with both energy efficiency and demand response. Small sensor here, and the idea was that when no one is around, you turn off all the lights in the cooler cases. So what we did is we went into grocery stores, sensor here, and what we found out was when you turned off all the lights, no one would drive down the aisle. Because they'd say, oh, it's broken. We shouldn't go in here. So now they're dimming down to 20% and everybody goes down. When I show these slides in China, I'm doing a program in China. When I show these slides, they all go, oh, look at all the food. It was like they were all really engaged in the... I told them that one of the standards that we're working on in California is regulating away stoves because Americans don't cook. They just use microwaves. And they actually listened. We were writing things down. Okay, so I've been called on time, so I'm going to take questions. Please.
Let me get a mic.
Okay. I can hear.
Okay. Okay. One is, are these in general cost effective? And two, what do you think are the mechanisms to force the retrofit market in this? And three, how do the rebates play in the IOU programs?
It's a long question. Cost effective, yes. And again, yes there's a long answer to the yes. I usually go after low-hanging fruit. The parking garages and the parking lots, you're looking at very rapid returns on investment. But in a university environment, it's sort of who cares? If you're going to be owning, UC Davis isn't going out of business anytime soon. So if they're going to own the building for 20 years, then let it be a 20-year payback. So what I always say is it cost effective? Yes. In terms of rebates, a lot of these things are very aggressive in terms of energy savings, and there are rebates for it. There are rebates for it. Now there was a middle question there. Remind me what the middle question was.
Forcing retrofit.
Yeah, I guess 90% of what I do is retrofits, even 95%. I try to stay away from new construction because most of the fun is in retrofits, and so it has to make sense on a retrofit level. And that's why most of the technologies that we developed are fairly light on infrastructure changes. We had big problems with the first RF system we went in because it required a lot of infrastructure, and it held us back a little bit. Now we're going back there now because we've simplified it. but it has to be very sensitive to the variability that you see in the field. And the big problem with the PLS, the task lighting system, was because every office is slightly different.
We went kind of late. Let's just take one more question.
Yeah, sorry.
Excuse me. So how do efficiency compares with Europe and Japan, for example?
Yeah. It's, in terms of what California is doing, California is very, very aggressive in terms of sort of the relative change. But if you look at the per capita, we're much higher. Okay, but we're more aggressive in terms of some of the in terms of some of the engagements on how we put technologies into play. If you map, an interesting thing is to look at the per capita consumption. You look at places like Japan or Europe, their per capita is a lot lower. Is a lot lower. Now they pay a much higher relative, absolute quantity for energy than we do. Energy here is very cheap, very inexpensive. But if you look at policies and integration, we're doing a lot of very imaginative things here. The last part of that is that the NEMA people that I mentioned, the industry people who are very adversarial, sometimes adversarial with the commission, in Japan, their NEMA is run by the government. And so you could argue church and state on this one, but which some people do. But it's interesting when they want stuff to happen, it happens. They want a controllable ballast, done. So because when the government speaks, the industry, it's their industry listening. Yeah.
Michael, thank you very much.
My pleasure.